In this question, we're asked to fill out a periodic table entry for tin. And we're given some mass spec data for two isotopes of tin, including their masses and their relative abundances. So the first thing we need to do is we need to find the atomic number of tin, because that's the number that goes on the top. To do that, we're going to need our periodic table. When we find tin on the periodic table, we find out that its atomic number is 50. So we can put up here 50. Now on the periodic table, as you'll see, as you've seen before probably, there are average atomic masses. So these on the bottom are the average atomic mass, which in this case for tin is 118.71. This is on Earth. This is some distant planet, so you may not get the exact same number when we do the question in a minute here. So this is the average atomic mass. So this is if you were to take all the isotopes and their percentages and add the contribution of the total mass to each isotope percentage together, this is the average atomic mass that you would get. Said another way, you need to take a weighted average of the mass and its relative abundance. To do that, you take the mass of the isotope, in this case 123.91, times its relative abundance, not as a 55, but since this is 55%, we write this as a whole number, 0.55, plus the other isotope times its relative abundance. So in this case, 121.90 times 0.45, which is 45% as a number. If you were to find a different atom which had several more isotopes, 4 or 5 or 6, you would take a weighted average of those in a very similar way. You would just have more numbers to add together. Now to do this, what we want to do is we want to multiply first the isotope mass times its relative abundance, which in this case will give us 68.1505. Since we multiplied, and this is 5 significant figures, and this is 2 significant figures, the relative abundances are measured numbers, this should have 2 sig figs. I don't want to round yet, but I do want to put a line under it, just to remember that this should be 2 significant figures. Plus, this isotope mass times its natural abundance. So we multiply these two, and we get 54.855. Again, for the significant figures, we have 5 and we have 2. So we just want to put a line under there. We don't actually want to round. We just want to put a line under there so that we know that that's the one we should consider. When you add these together, you get 123.0055 as a number. In this case, we added. So this has 0 decimal places, and this has 0 decimal places. So our answer should have 0 decimal places. So the best answer here is 123. So we should put 123 for the average atomic mass. It's really important to know where this comes from and how this math works, because on a periodic table, this has all been done for you on Earth. The average atomic mass, for example, for carbon is 12.01 grams per mole. And there are, for carbon, roughly 3 isotopes that are fairly abundant, although one of those 3 isotopes is only abundant in a very, very small percentage.